Okay, so 5.2 exponential functions. This will be day number 2. In day 2 video, you are going to see all graphing of exponential functions. Okay, so we'll do one more where we use an XY chart. We'll look at some characteristics of exponential functions, and then we will get into graphing exponential functions using our transformations from way back. Okay, so it's going to be important you remember your transformations, so let's get started. Okay, first one I'm going to show you. Yesterday I showed you 2 to the x, which was an example of an exponential growth, because from left to right it's going up. Today I'm going to show you an example of an exponential decay. This one from left to right will be going down. Okay, so when I do this, I wanted to show you, you might be able to figure out how I got that. If you're not quite sure, no big deal. It's okay if you don't know how I got that. If you want to leave it 1/2, I'm going to show you right now how I could leave it 1/2. So here's what I'm thinking. I could do 1/2 to the negative third power. So I know my rules of exponents, I'm allowed to distribute that. Okay, so from here I know I make my negative exponents positive by simply switching their location. And then 2 cubed I get 8, 1 cubed I obviously get 1. Okay, so understanding that when I do 1/2 to the negative third power, I simply get 8, do 1/2 to the negative second power, yada yada yada, all the way down. There is your XY chart. So what I'm going to do is plot those points. I'm going to connect them. Same rules are going to apply. I know that what I have down here, that dotted line, I know that dotted line is still going to be y equals 0, which is still my horizontal asymptote. Don't get that confused. It's the point, right? It's the line. It gets as close as it possibly can get to it, but it never actually crosses that line, so we call it a horizontal asymptote. And I showed you that this is an example of an exponential decay. Okay? So, based on those 2 graphs that we just did, the exponential growth, which was 2 to the x, and the exponential decay, which was 1/2 to the x, what are some characteristics that you notice about exponential functions? So here is the general form of exponential functions that we're going to be talking about. See if you can fill out as many of these as you possibly can. Why don't you try to pause the video, see if you can fill out any of these based on looking at those first 2 graphs that we did. Is it 1-to-1? Obviously, yes, it passes both the vertical and the horizontal line test. Domain, what x values are being used. You should be able to say, okay, all reals, all of them are being used. The range, though, I think the range, the y values being used are 0 to infinity. Notice that I have a parenthesis on 0 because it never actually touches 0, so no bracket. What was the y-intercept? Well, the y-intercept was 0, 1. For increasing and decreasing, if you want to change these words, instead of increasing, if you want to put the word growth there, maybe that'll help you. And instead of decreasing, if you want to put decay, maybe that'll help you as well. So when was this thing a growth? I'm basically asking you, what did the b value have to be in order for this thing to grow exponentially? And same deal, what did this b value have to be when it was a decay? So I know it's going to be a growth when b is greater than 1. So when it was a whole number greater than 1, 2, 3, 4, 5, etc., it's always going to be a growth. And when it's a fraction, when b is in between 0 and 1, right, that's how I get a fraction, then it's going to be a decay. And then asymptotic, well, where was the asymptote? It was asymptotic to that line y equals 0. So there is where my asymptote was. Okay, so hopefully you did okay on those. E and F might be the ones that you had trouble with, but let's keep going. All right, so here we go. Letter A and letter B. For letter A and letter B, the first thing I want you to do is to identify what the parent function is going to be. The bad news is that the parent functions aren't always going to be the same. The good news is that you're still going to apply your transformations like you did in the past. So for letter A, I'm going to tell you the most basic parent function would simply be 2 to the x. So I figured out, I'll give you an idea, I looked at what the base was. Then I said, okay, I'm going to use that base to the x as my most basic parent function. Okay, so take a glance at letter B. What do you think your parent function would be for letter B? Think about that as we keep going. So I know my most basic parent function in letter A is 2 to the x. And then I see 2 transformations. Okay, so understanding you got 2 transformations there. There they are. Okay, so before my horizontal shift left and right was in parentheses. Now with exponential functions, there is going to be your horizontal shift. Obviously, -1 goes to the right, +1 would go to the left. Same deal as before. And then obviously this +2 is going to be my vertical shift up 2. Okay, so what I'm going to do is graph my most basic parent function first. So 2 to the x. So I'm going to think, okay, 2 to the 0 power is 1. So I know the 0.01 is on there. 2 to the first, 2 to the second, 2 to the third, 2 to the -1. Okay, so I'm going to keep doing those parent functions. Keep doing those x values. There is my parent function. Notice that you also have to draw the asymptote there as well. So there is my parent function. Okay, so from here, I'm going to take each one of those points. I'm going to take this point right here. I'm going to shift it right 1 and up 2. Right 1 up 2. That one's obviously going to move there. Take the next point, which is right here, shift it right 1 up 2. Keep doing that as you keep going. You should get something that looks like that. Think about it. If I take my asymptote and I shift it right 1, is that thing going to move at all? Nope, it's just going to shift right, which it's still going to be at the same place. But when I shift it up 2, I know it's going to move. So I'm going to move it up there. I'm going to label it. I'm going to draw my graph, and voila, that's done. I know in the past, some people, they liked to shift and move their asymptote first. That made drawing these last couple of points a little bit easier. If that's going to help you to move that asymptote first, great. I think you should absolutely do that. Honestly, it makes graphing these last couple of points so much easier. So maybe you want to think about doing that for this next one. Okay, so letter B. Let's try it again. My most basic parent function. Hopefully you at least attempted it before. Let's see how you did. My most basic parent function would simply be 3 to the x. I took the base. It was a 3. I just put it to the x power. Voila, it's 3 to the x. That means that I have 3 transformations in this problem. Okay, what are the 3 of them? Well, I know that I got a horizontal shift to the left one. I know this negative on the outside is a reflect x. And then I know that -2 is a vertical shift down 2. Okay, so think. Let's graph our parent function, which is 3 to the x. So think about that. 3 to the 0 is 1. 3 to the first is 3. 3 squared is 9. Okay, that point is way up there. Hopefully you're not going to get too confused with how we're going to move that point. We'll talk about it. Okay, so 3 to the negative first, 3 to the negative second, my asymptote. Okay, so I know there is my parent function. Alright, so let's focus our attention. I'm going to do this point with you, start to finish, because this one might be a little difficult. Okay, here we go. Ready? So some things that I know already about this point. I know it's at 2, 9, because 3 squared is 9, so I know it's at 2, 9. If I shift it left 1, I know it moves to 1, 9. If I reflect it over the x-axis, now I know it moves to 1, negative 9, and then if I shift it down 2, it moves to 1, negative 11. So, oops, didn't want to do that. Don't look, don't look, don't look. Go away, don't look. So I know it moves to 1, negative 11. Okay, the rest of them should be fairly simple at this point. Take this next point right here, shift it left 1, reflect x, and then down 2. That puppy should be right there. Do the same thing. Again, if it's going to be easier for you to move your asymptote, then move it. Think left 1, okay, the asymptote's not going to move. When I reflect x, guess what? That asymptote's not going to move. If I shift it down 2, I know that asymptote's going to move down 2, so maybe if you want to do the asymptote first, great. Don't forget you also want to label that thing, y equals negative 2. And voila, there is graphing our exponential functions using our transformations, and good job.